So we look at questions 16 and 17. So bromine has two isotopes, 79Br and 81Br. The only difference between these two isotopes is the number of neutrons. The number of protons, the atomic number or the proton number at the bottom is the same. So they've got the same number of protons and the same number of electrons. The only difference is their mass has changed because the number of neutrons has changed. So the first ionization energy is less than the first ionization energy of 79 is different than 81. Well, no, it's not, because the ionization energy depends on the nuclear attraction of the number of the protons from the nucleus and the number of electrons and shielding and so forth. But the number of protons and electrons are identical in both, so the ionization energy is going to be the same. The atomic radius, again, the atomic radius depends on the number of electrons, the number of electron shells, and the number of protons in there. But they've got the same number of protons, so the nuclear attraction. But the nuclear attraction number of protons and the number of electrons and electrons in shells is identical, so the atomic radius is going to be identical. Reactivity depends on the number of electrons in the outer shell, so the reactivity is identical because the number of electrons are the same. The only difference is that the mass spectrum has two different molecular ion peaks. So what that means is, if you take a molecule and you make it plus by removing an electron in a mass spectrometer, and then you measure its mass, then the mass will change depending on whether Br has got a 79 Br with a mass of 79 or 81 Br. So in this sample you could have Br as a 79 or Br as an 81 just naturally occurring, and both would occur, both would be around in nature. And then when you make it a positive ion, a molecular ion, and measure its mass, then you'll find that its mass is different in each case depending on whether the Br is a 79 Br or an 81 Br, so its mass changes between the two molecules depending on what kind of isotope of Br is in there. Which of these is not planar? So planar happens if there's 3 bonds off a carbon. As soon as there's 4 bonds off a carbon, then it becomes tetrahedral in shape. So in other words, which one is not planar, not have 3 bonds, which has 4 bonds? So CH3CO, there's a carbon to hydrogen bond, a carbon to hydrogen bond, and a carbon to double bond oxygen, which counts as 1 bond, 1 species. There's 3 different atoms off that carbon. That one's planar. 3 different H's off that one. Forget about the plus, that's not important. There's 3 different H's off that one carbon. That one's planar. This carbon has 3 H's, no H. It has 4 different groups around it. That's tetrahedral. C2H4 has a carbon-to-carbon double bond, and each carbon then has 2 H's. So it's got 3 different bonds or 3 different groups attached around each carbon. That's planar. This one, CH3OH methanol, has 4 different groups around the carbon. That's not planar. It's tetrahedral.